Hello guys, so we are back again, and in this session we are going to cover more questions okay on the topic which we have started considering variables as constant while differentiating, partial differentiating. So in the previous lecture we have completed two questions, and I had given you some preview what we are going to do in that section, right? And in this session we are going to do some more pretty questions, some good level of questions. But before starting with the session, hope you have subscribed the channel, so that we can bring more engineering content to you guys. So the question which we are starting with is as follow: if u dot u into x plus v into y equals to 0 and u by x plus v by y equals to 1, prove that u by x into dou x by dou u keeping v constant plus v by u into dou y by dou v keeping u constant equals to 0. So to prove this, firstly, in dou x by dou u, we require x as a function of u and v. So what we are going to do? We are going to eliminate what? We require x as u and v. So y should be eliminated. Y value we can get from here. Y will be what? Minus ux by v. Now this is given. We substitute. Substitute it in what? U by x plus v by y equals to 1. This is what they have given. If we substitute in it, what we are going to get? U by x plus, you will write it in the next step, but I am writing it here. U plus v by, I need to eliminate y, so I am going to substitute this minus ux into v equals to 1, right? What I am going to get? Minus u square, I am take 1 by x outside, I will be left with plus v square the whole by what? Minus u, right? Minus u equals to 1. Not minus u. What we can do here, we will shift this minus, this will become plus. Let me make you understand this step more clearly otherwise you will be confused. U by x minus v square by ux. I just move this sign here, equals to 1. If I take 1 by x common, I will be left with u by 1 minus v square by what? U equals to 1. I will move the now what term I require? I required x. I required it in terms of x, so I should have x equals to u and v function. So I will move the x, so x equals to what? U square minus v square by u. So I'm getting one equation. I will call it as 1. This is my equation. So dou x by dou u keeping v constant will be what? Dou by dou u. X is what? U square minus v square by u. I will differentiate it, which will give me u square the whole u into 2u. 2u, right? 2u minus u square minus v square into 1, right? If I simplify this, 2u square minus u square plus v square by u square, I will be getting u square plus v square by u square. Call it as 2. Now what we want in proof? U by x. So u by x into dou x by dou u keeping v constant is nothing but u by x into u square plus v square by u square, which is nothing but u square plus v square by ux. Call it sum 3. Now similarly in what? In dy by dv by u. Dy by dv keeping u constant, we require y as a function of what? V and u, right? So what we are going to do? We are going to eliminate x. How we are going to eliminate? Using this equation. So I can write x equals to what? Minus vy by u. Simple. We will substitute in this equation. u by x plus v by y equals to 1. If I substitute x, I am going to get u by minus vy here by u plus v by y equals to 1. This is what given, right? After substituting, I am getting this. After, if I move this, I will be left with this minus vy. This minus has moved up, plus v by y equals to 1. Now I require y is a function, so y should be on one side and the function should contain v and u. So I can take y common and move it that side like I did previously. So y equals to, I will be left with minus u square by v plus v square by 1. If I cross multiply, I will be getting v square, sorry, this is v square minus u square by v. So I am getting my y function. Now I will differentiate it with respect to x, keeping, okay, you can give it some 4 or it's up to you to know the teacher that you have calculated it. So dy by dv, keeping u constant, is nothing but d by dv. You have to put this value v square minus u square by v, which will be nothing but v square into v into 2v, right? 2v minus v square minus u square, here it will be 1. If I open this, I am getting v square, this is 2v square, 2v square minus v square plus u square, the whole by v square. I will be getting what? V square plus u square, the whole upon v square. Okay. Now dy by dv, keeping u constant. So if I do this, what I'm going to get? I'm going to get, okay, this thing which I'm getting. So I will call it some, okay, let's call it 5. Now what we require in this is v by y into dy by dv, keeping u constant. So what I'm going to do, I'm going to multiply it with v by y into dy by dv, keeping u constant, is nothing but v by y into what? V square plus u square, right? The whole by v square. What I'm going to get, v will cancel out. I'm going to get v square plus u square, the whole by vy, right? Okay, so I'm getting this thing. I will call it what? I will call it, this one I called it 3, this one I will call it 4. Okay, the previous one. So from 3 and 4, okay, what I can write? ux into dx by du v plus v by y dy by dv is nothing but what we have, u square plus v square upon ux plus v square plus u square, the whole upon vy. I will take u square plus v square common, 1 by ux plus 1 by vy is as it is, giving me ux plus v square into ux plus vy, the whole upon ux vy. Now if you observe, one thing was given that ux plus vy was equal to 0, so this should be equal to 0, so the whole expression value will become 0. Okay, since the numerator is 0, so no matter what it is divided by, it will always remain 0, and when it is multiplied by anything, it will also be 0. So our answer is 0. So we are done with this problem. Hope you understand each and every step. Now let's move on to the next question. So the next question which we are going to do is as follow. Let me take the question. The question is this, although it looks similar but it is different. Okay, it says if ux plus vy, okay, u into x plus v into y equals to 0, u by x plus v by y equals to 1, prove that dou u by dou x keeping y constant and dou v by dou y keeping x constant is equals to x square plus y square, the whole upon y square minus x square. So here which one is difficult to get? Okay, u as a function of x and y, u as a function of x and y, we need to eliminate v, and here v as a function of yx, we need to eliminate what? U. So in dou u by dou x keeping y constant, we require u as a function of x and y, right? U as a function of x and y. So what we are going to do, we are going to substitute v value in this equation to get it in terms of u only. So v will be what? Minus ux by y from this equation. If I substitute it here in v by y equals to 1, given this equation was given, what I'm going to get is u by x. This will be what? Minus ux by y square, right? Equals to 1. I will take, now I want in terms of u. Okay, so u should be one side and the rest of the function should be in terms of x and y. I will keep my u outside. This will be y square minus x square, the whole by xy square should be equal to 1. Therefore my u will be what? Xy square, the whole by y square minus x square. I will call it as sum A. Now what I want, this value I got that, which is this. So du by dx, keeping y constant, is nothing but d by dx into xy square, the whole by y square minus x square. Now we are differentiating with respect to x, so y is some constant, so what I'm going to do, take it outside. So d by dx into x by y square minus x square is the actual thing which I'm going to differentiate, right? So what I'm getting is y square minus x square, okay, and here what we will get is the whole upon y square minus x square, the whole square. This will be 1 minus y square minus x square, sorry, here it will be x, this will be what? The difference minus 2x. So we are getting this. After this y square minus x square plus 2x square, the whole by y square minus x square, the whole square, right? So if I simplify this, what I'm going to get? y square plus x square, right? Y square plus x square, the whole upon y square minus x square, the whole square. So we are getting this thing into y square. Okay, so let's leave it as it is. Now let's call it sum 1. Now in the second, in dv by dy x, we require v as a function of x and y. Don't you agree? Okay, we require v as a function of x and y. So what we are going to do, we are going to get u value from this, minus vy by x, minus vy by x. So if I substitute this value in this equation, what I want in terms of what? V. So I'm going to substitute u value, so minus vy by x square plus v by y. I require my x, so one side x should be, v should be there, and rest should be the equation. So I'm finally going to get, so this is my required equation, I will call it as B. So dv by dy, keeping what? X constant, will be what? Will be d by dy into x square y by x square minus y square. If you observe, I am differentiating with respect to y, so x square will be constant, so I am going to get this thing, x square minus y square, the whole square. Here x square minus y square into, I will differentiate this, which will be what? 1 minus this will be y as it is, and here what I am going to get is minus 2y. If I further simplified, x square will be as it is, it will be x square minus y square plus 2y square, the whole upon x square minus y square, the whole square, this thing. Finally we are going to get x square plus y square, the whole upon x square minus y square, the whole square, right? So this thing is the thing which is left. So let's add them. Okay, let's call it sum 2. Let's add them. If I add them, what I am getting, if I add them, I am having, let me get the page ready. So if I add them, I am having one, at one place I am having, let me get the values. Okay, I am having y square into y square plus x square, y square plus x square the whole by y square minus x square. Okay, and here in the next I am going to have this second I can get what, x square into x square plus y square the whole upon y square minus x square, the whole square, here also the whole square. So what we can see that if you observe, okay, we can convert this into y square minus x square. Since it is square, it doesn't matter. So if I convert it, I can take the whole thing common, y square plus x square the whole upon y square minus x square the whole square, and here I am left with y square plus x square the whole square. Okay, so what I am getting, x square. So we are getting this thing. Now what we can do, we can do one thing, we can multiply and divide by minus sign. So what will happen, okay, I think we have did a mistake. In starting only we should have converted. While converting this, when we calculated, we have to convert it into y square minus x square. So this will be what, this is as it is. Okay, let me convert it in the next step. V equals to minus x square y by y square minus x square. Okay, this answer should be in this format. Okay, as it is required in the proof. And here luckily we got that similar thing, so we didn't think about that. In the first, when we started, we automatically got v square minus x square, but here we have to make it similar to the previous one. So here will be nothing, not a big change. Here it will be minus automatic, here there will be plus, this will be minus. Let me calculate the v we got. Let me calculate dv by dy again. So if I calculate dv by dy, keeping x constant again, what I am going to get, d by dy, sorry for that mistake, here minus sign will be there and y square minus x square will be there. So what I am going to get is y square minus x square the whole square. So if I take here y square minus x square and differentiate, since it is differentiating with respect to y, we are going to take x outside and keep this minus side outside. We are going to get this thing as 1. Here we are going to get something y. Okay, and here what, 2y, right? If I simplify, I am going to get minus 2x square y square minus x square minus 2y square the whole by y square minus x square the whole square minus x square. This will be what, minus x square minus y square the whole upon y square minus x square the whole square. This will become plus, so x square into x square plus y square the whole upon y square minus x square the whole square. So I think we are getting the same thing. We are getting the same thing, or what, x square by just, okay, we are getting the same thing only. Okay, we are getting the same thing, just this thing is just a little bit changed. So not a big change. If I do the here y square plus x square, here the denominator will be same, y square minus x square the whole square plus x square into x square plus y square, right? So we will take x square plus y square common. If I take x square plus y square common, I will live with y square minus x square the whole square also in the top, and here x square plus y square. So let me check. Okay, so let me check. We are doing some mistake or what? We require what? Du by dx minus dy by dz. Okay, we are doing some plus thing. Okay, here it will be minus. Here it was minus, we did plus here. We did plus, okay. I thought that here, since we have not converted, that may be a reason. Okay, so I checked. Okay, both the answer came similar only, but you have to move in this direction by observing the proof. So here, if it is minus, so what I am going to left with, here it will be what? Y square minus x square left. So if you observe, this and this will cancel out, and I will be left with x square plus y square upon y square minus x square. So just a simple mistake, because of which we were stuck in the final step. So please avoid this mistake. Observe the question carefully. Like here I added both of them, because of which I was stuck here. Now we have done this. Hope you have understand. And whenever you do this type of proofs, just try to convert it in the similar format. Like here we got this, and in here you have to convert it in the similar format of y square minus x square. Now let's move on to the next question of this session. So the next question which we are going to take is as follow. If x square equals to a under root u plus b under root v, and y square equals to a under root u minus b under root v, where a and b are constant, prove that dou u by dou x keeping y constant and dou x by dou u keeping v constant is equals to 1 by 2. So here dou u by dou x, this, okay, where u is differentiated with respect to x and keeping y constant, there is no such equation in which we have u, x and y. Okay, you can observe. But here x, y, u, v, this equation exists, okay, already present. So we don't need to worry about that. So we will first get this. So in dou u by dou x keeping y constant, we require what? We require u as a function of x and y. For that we will add both of them. X square plus y square, you can easily see they will cancel out, and 2a under root u you will get. Since my main focus is to get what? U as a function of x and y, I will do this, the whole square by 2a under root u. I need u only, so u will be what? X square plus y square the whole by 4a square the whole square, right? Now what I want, dou u by dou x keeping y constant, which is dou by dou x square plus y square the whole by 4a square the whole square, right? So what we are going to get here is, I will take 1 by 4a square common and differentiate this. If I differentiate this, I am going to get 2x square plus y square firstly into 2x, right? If you observe, 4 will cancel out, and we will be left with something u square plus v square. But u square plus v square is nothing but 2a under root u. So I can call it as 2a under root u by a square into x. A will get nullified, and I will be left with 2x under root u by a, right? I will call it as sum 1. Nextly, what we are going to do, du by d. So we got this thing. Now our target should be this. So du by, you can write this. We have x as a function of u and v. Therefore dou x by dou u keeping v constant is nothing but dou by dou u. We can write this equation, which is what? X square, which if I differentiate, it will be, if I differentiate, what I'm going to get? I'm going to get, if I differentiate this, I'm going to get a by 2 times under root u, and since it is x square, this will also be differentiated, and finally what we will get, let me, okay, many children forget this step, that since they are not differentiating x, they are differentiating x square. Now why don't you tell me that, why don't you take x, okay, as you have mentioned throughout the chapter that we will create x as a function of both. If you create, this will become whole under root. Okay, then you have to differentiate 1 upon 2 times under root this, and then further you have to eliminate this using the same equation. Okay, which will be a troublesome. Okay, when such situation arrive, you have to go with x square. So what I'm going to get, 2x dx by du, giving you what we have, a by 2 under root u, right? This 2x will move here, we are left with a by 4x under root u. So this is what our dx by du, keeping what v constant. So what I wanted dou u by dou x keeping y constant into dou x by dou u keeping v constant, which is nothing but what I'm getting, a by, I got 2x under root u by a into, from here I got a by 4x under root u. If you observe, we are getting 1 by 2, which is what they wanted to prove us, hence proved. So hope you have understand each and every step. So we are done with variables, solving partial differentiating, considering variables as constant. So in the next session we are going to begin with the chain rule, whose little bit of taste you have already taken when we were solving second and third order higher order derivatives. So see you in the next lecture, and don't forget to subscribe the channel. Hope you like our content, so that subscribe the channel so that we can bring more content to you guys. Thank you.